follow. Centigrade scale and Fahrenheit scale are equal. Equal or same. At what temperature? Centigrade scale, Fahrenheit scale are equal or same. Relation between C and F.
So minus 40.
Yes, correct. So C by 5 is equal to F minus 32 by 9. So let C is equal to F is equal to X. So X by 5 is equal to X minus 32 by 9. So 9X equal to 5X minus 160. 9X minus 5X is equal to minus 160. 4X equal to minus 160. So X equal to minus 40. X equal to minus 40.
PDF there, sir.
At what temperature? Both are equal. Centigrade and Fahrenheit scale are equal. At what temperature? The readings of centigrade scale and Fahrenheit scale C and F. The reading of centigrade scale and Fahrenheit scale are in the ratio is 2:3. So C by F is equal to 2 by 3. F by C is equal to 3 by 2.
3 by 2.
F equal to 3 by 2 C. So answer in terms of C now. So F is eliminated. For example, answer in terms of F, C eliminated. Okay. So we know that C by 5 is equal to F minus 32 by 9. Right. So 9C by 5 is equal to F minus 32. So 9C by 5 is equal to 3C by 2 minus 32. So 32 is equal to 3C by 2 minus 9C by 5. So 32 is equal to LCM 10, 15C, 18C. 320 equal to minus 3C. 3 equal to 320 minus 320 by 3.
Minus 40 answer, sir.
Minus 320 by 3 centigrade or
Minus 107 degrees or 106 degrees.
0.6
6, 7.
Next one.
So just a minute, sir. Don't drop.
Oh, okay, right.
సార్ ఇది 2:3 రేషియోని 2x 3x తీసుకుని కూడా చేయొచ్చు కదా సార్?
ఏనా
సెల్సియస్ టు ఫారెన్హీట్ రేషియో 2:3 ఉంది కదా సార్?
ఓకే,
అది 2x ఇంకా 3x తీసుకుని చేయొచ్చా?
చేయొచ్చు.
ఓకే సార్.
రేషియో చేయొచ్చు.
అంటే అలా వస్తుంది, కరెక్ట్ ఆన్సర్ వస్తుంది లేదా అని అడిగాను.
వస్తుంది ఎక్స్ వాల్యూ క్యాల్కులేట్.
ఓకే సార్.
Getting same answer.
So we can find F now, sir.
For example, find F. Actual answer is centigrade, sir. Centigrade. For example, F C is equal to 2/3 into F. Substitute. Based on answers, options. Options all are centigrade. Okay. Okay. General method of measuring temperature. Measuring temperature. General method of measuring temperature. General method of measuring temperature. Okay. So let parameters of ice, steam, and unknown temperature,
Scale.
temperature respectively. Unknown temperature respectively. So actually this is the one formula. Next subchapter this week, expansion of solids, expansion of solid liquid gases, expansion of solids. So actually expansion of solids, alpha is equal to L2 minus L1 by, so L1 into T2 minus T1. How, sir? For example, this is the one rod. Rod length L1, temperature is T1 degrees. Temperature is increases, so T1 to T2. So T1 to T2. Length also increases, is L2. Temperature increases from T1 to T2, length also increases. The change in length and L2 minus L1 is directly proportional to initial length and directly proportional to temperature difference. So therefore, L2 minus L1 is equal to L1 into T2 minus T1, proportional to T2 minus T1. So L2 minus L1 is equal to some alpha into L1 into T2 minus T1. So what is alpha? Alpha is the coefficient of linear phase. This is the proportional constant. Proportional constant. This is the alpha. This is the proportion. Proportional. Alpha is the alpha equal to L2 minus L1 by L1 into T2 minus T1. This is the coefficient of air expansion. So air expansion means A2 minus A1 by A1 into T2 minus T1. Cubical expansion means V2 minus V1 by V1 into T2 minus T1. Cubical means in change in volume. Aerial expansion means in area. So linear expansion means in length. So next expansion of solid chapter. Similarly, same in this concept. Okay. Alpha is equal to xt x2 minus x1 by x1 into t2 minus t1. So xt minus x1 is equal to x1 alpha into T2 minus T1. This is the formula. Okay. So we know that. So alpha equal to x2 minus x1. X is the parameters. For example, if the temperature increases from 0 degrees C to T degrees C. 0 degrees C to T degrees C, one relation. 0 degrees C to 100 degrees C, another relation. So, right, this is also first one xt minus x naught alpha into T minus 0. This is the one equation 1. Similarly, if the temperature increases if the temperature increases from 0 degrees C to 100 degrees C. The temperature increasing from, okay, right. So, same model, x100 minus x0. x0 alpha into 100 minus 0. This is the equation number 2. So, equation dividing 1 by 2. Equation 1 by equation 2. So, xt minus x0 by x100 minus x0 is equal to x0 alpha t by x0 alpha into 100. x0 alpha cancel. Therefore, t by 100 equal to, so xt minus x0 by x100 minus x0. This is a final formula. Final formula important. So n is equal t by 100 equal to xt minus x0 by x100 minus x0. This is the formula. So general method of measuring temperature. So t by 100 or c by 100 equal to xt minus x0 by x100 minus x0. xt, x0, x100 be the parameters like a pressure, volume, resistance or anyone. So t degrees C, 0 degrees C and 100 degrees C. So then t by 100 is equal to xt minus x0 by x100 minus x0.
So this is for Celsius scale only, no, sir?
Celsius scale.
Sir, if they give Fahrenheit, we need to take one.
Maximum is a Celsius scale. All maximum Celsius. 99% Celsius scales.
Okay, sir.
Sir, excuse me, sir.
Tell me, Anna.
Sir, give side, sir. 1 minute. I would.
Sir, finally we have to remember this last formula.
Final, remember that this is the formula. Just only for proof. This is the only for proof. Final formula important. Actually, this is also not important. Just this is the formula important. Relation formula important. T or C by 100. T by 100 or C by 100 is equal to R xt minus x0 by x100 minus x0.
So same S minus lower fixed point formula also. No, sir. That S minus lower.
Maximum, this concept maximum centigrade, maximum 9-10% centigrade. The only temperature calculated. Temperature.
ఒకవేళ ఫారెన్ హీట్ లో ఇస్తే సెల్సియస్ కి కన్వర్ట్ చేసుకోవాలా?
ఫారెన్ హీట్ ఇవ్వదు. మెటీరియల్ ఆల్ ప్రాబ్లమ్స్ ఓన్లీ సెంటిగ్రేడ్.
లాస్ట్ కి వచ్చిన ఆన్సర్ దాంతో కన్వర్ట్ చేసుకోవచ్చు కదా సార్ డైరెక్ట్.
జస్ట్ ఓన్లీ లాస్ట్ ఫైనల్ ఆన్సర్ కన్వర్ట్ చేయండి. ఇన్ కేస్
Done, sir.
Completed,
Completed, sir.
Yes, sir.
Right.
Sir, what is X here?
So types of X parameter. Any parameter like Rajan by any parameter like pressure, volume, temperature. Right. So types of thermometers. So there are 7 types of thermometers. So first one is the liquid thermometer. First one is the liquid thermometer. First one. So liquid thermometer, constant volume thermometer, constant pressure thermometer, resistance thermometer, thermoelectric thermometer, radiation thermometer, vapor pressure thermometer. There are 7 thermometers are there. So first one is the liquid thermometer. Under triple point of water. So temperature syllabus close.
Sir, no expansion of solids.
Right. Okay. This is the final formula. Okay. What is the liquid thermometer? First thermometer is liquid thermometer. Mercury is used as liquid. In this thermometer,
Sir, alcohol does not come in this.
huh?
Alcohol thermometer.
Tell me now.
Alcohol thermometer.
No. This is not there. No. Only 7 thermometers in intermediate level. Mercury thermometer. Mercury. Right. So in this thermometer, mercury is used as liquid. Is used as liquid. Mercury is used as liquid. So second one. It is low specific heat. It is low specific heat and high conductivity. High conductivity. What is the specific heat? Actually, original in calorimetry chapter, S is equal to 1 by m into dq by dt. Temperature. The amount of heat energy required per unit mass of a substance to 1 degree rise of temperature. To 1 degree rise of temperature is called specific heat. Specific means it means the amount of heat energy required per unit mass of a substance per unit degree rise of temperature is called specific heat. Specific heat, net capacity, latent heat. This is the original topics in calorimetry chapter. This value, specific heat value is low. And what is the conductivity? In second year, conductivity means this is the conductivity. Reciprocal of resistivity is called conductivity. What is the resistivity? R is equal to rho L by A. Resistance depends on dimensions, length and area. Directly proportional to length and directly proportional to area of the conductor. So is the rho. Rho is the proportional constant is called resistivity. So rho is equal to RA by L. So this is called resistivity.
Sir, if less resistance, then more conductivity.
Yes. S equal to rho A by L. So resistivity is either length or area. So resistivity directly proportional to area, inversely proportional to length. Inversely proportional to length. This is the resistivity. So we substitute actually conductivity means L by RA. Okay, na? L by RA. So conductivity is directly proportional to length and inversely proportional to area. So conductivity is the high conductivity. High conductivity.
So it means low resistance.
Liquid thermometer has high conductivity and low specific heat. Okay. Right. So third one. This thermometer can be used. It can be used. It can be used minus 38 degrees C to 360 degrees. Minus 38 degrees C to minus 360 degrees, up to 360 degrees. So this thermometer can be used minus 38 degrees C to 360 degrees. Next one, fourth one. Fourth one. Right. Let LT, L0, L100 be the length of the mercury. Length of the mercury column. Mercury column. Then, so T by X by T by 100 is equal to XT minus X0 by X100 minus X0. Similarly, T by 100 is equal to LT minus L0 by, so L100 minus L0. So T by 100 equal to LT minus L0 by L100 minus L0. This is called liquid thermometer. So liquid thermometer, mercury is used as liquid thermometer. So there are more thermometers in liquid thermometers. Okay, in hospitals also liquid thermometer, mercury thermometers. So it is a low specific heat and high conductivity. It can be used minus 38 degrees C to only 600. Limits only in between them. So minus 38 to 360 degrees C. And LT L0 be the length of the mercury column. So then T by 100 equal to LT minus L0 by L1 minus L0. Same previous formula, just substitute. L in place of X.
Sir, what is that last word, sir, in fourth statement? In fourth statement, what is that last word? Mercury?
Column.
Mercury column, then mercury. So that implies T is equal to LT minus L0 by L100 minus L0 into 100. This is a one type of thermometer completed. This is a liquid thermometer. Formula important. LT, L0, L100 are given.
Exam expansion of solids layer, sir.
No. Expansion of solids alpha, beta, gamma and relations. Only one application. Actual number of applications are there. Only one application.
So this is not
Variation of density occurrence.
One application there. So today completed temperature.
So this means solids are there, sir.
So you need any extra class, sir?
Sir, extra class is good, sir.
Right. So completed this one. So next one, second, constant volume gas thermometer. Volume gas thermometer. So constant volume gas thermometer. So second one, right? It is most accurate thermometer. This is most accurate thermometer. This is most accurate thermometer. It obeys Charles law. It obeys Charles law. What is Charles law? It obeys Charles law. At constant volume, the pressure of a given mass of a gas is directly proportional to absolute temperature. This is called Charles law. Charles law, two laws, first law and second law. Second law is also Gale's law also second law, or first law second law. First law is constant pressure, constant volume. Second law is constant pressure. At constant volume, the pressure of a given mass of a gas is directly proportional to absolute temperature. This is called Charles law, Charles first law. So in this thermometer, volume constant. Volume constant. Same word let her. Volume constant means pressure variable. PT, P0 and P100 be the pressure of a gas at T degree C, 0 degree C and 100 degree C. 100 degree C at constant volume.
So once clean your camera.
Constant volume. Is that clear?
కొంచెం బ్లర్ ఉంది సార్.
Yes, sir.
Yes, sir. Now okay.
Clear ఎందుకంటే వైఫై అండ్ అలాంగ్ విత్ వైఫై.
సో షేర్ స్క్రీన్ చేసి మీ కెమెరా యాప్ ఓపెన్ చేస్తే చాలా క్లారిటీ వస్తుంది సార్. షేర్ స్క్రీన్ చేసి మీ కెమెరా ఓపెన్ చేస్తే చాలా క్లారిటీ వస్తుంది జూమ్ లో.
అంటే షేర్ స్క్రీన్ ఎలా చేయాలి ఇప్పుడు?
లాగ్ కూడా అయితే
ఆప్షన్ ఉంటుంది సార్ షేర్ స్క్రీన్ అని.
షేర్ స్క్రీన్ సార్
అక్కడ ప్రెస్ చేయండి.
లాగ్ చాలా ఉంటది సార్. సార్ వద్దు.
లాగ్ అవుతుంది సార్, వద్దు సార్.
ఓకే ఓకే
యాక్టివ్ ఉంది సార్.
రైట్. Let PT, P0 and P100 be the pressure of a gas at 0 degrees C, 0 degrees, 100 degrees at constant volume. So then, same T by 100 is equal to PT minus P0 by P100 minus P0. Same P in place of X. So T by 100 is equal to PT minus P0 by P100 minus P100. Final formula important. So main point, fifth point. This term it can be used. It can be used to measure from 0 degree C to 600 degree C. From 0 degree C to 600 degrees. It can be used to measure from 0 degree C to 600 degrees C. Up to 600.
So in liquid thermometer, mercury used, here pressure is used, sir.
38, minus 38 to 360. Mercury thermometer.
No, sir, here pressure is used to measure the temperature.
This is the constant volume thermometer. Constant volume thermometer means pressure variable. Temperature changes. For example, temperature changes. This is also same. What is the PT, P0, P100? PT, P0, P0 is the pressure of a gas at 0 degree C, 0 degree C, 100 degree C. Temperature changes, pressure also change.
Okay, sir.
Level of the pressure changes. Okay?
Sir,
volume constant.
Sir, కానీ సెల్సియస్ స్కేల్ మాక్సిమం 100 కదా సార్? 600 degrees Celsius ఎట్లా వస్తుంది?
It's not a centigrade అన్న. ఇది maximum అంటే this temperature అంటే ఇక్కడ not a Celsius scale ఇక్కడ.
ఓకే ఓకే సార్.
Right. Second one is constant volume thermometer, constant volume gas thermometer. Next, constant pressure. Then the constant volume, sorry, constant volume thermometer, sorry, just wait. It can be used, second constant pressure thermometer. It can be used minus 200 degrees C to minus 200 degrees C to 1500 degrees C. Sorry, minus 1500 degrees. 1500. Minus 200 degrees C to 1500 degrees C.
Sir, which gas is used in the thermometer, sir?
Huh?
Which gas is used in the thermometer, sir?
Which?
Gas is used in the thermometer.
Yes, this is also only for volume constant.
Sir, which gas?
No, sir. Which gas, sir? Gas, sir.
Not a gas means this is also like helium, neon, not only one liquid, any gas.
Okay,
Some
sir.
gases.
Okay, sir.
Available gases.
Okay, sir.
Right. So next one is constant pressure thermometer. Constant pressure thermometer. Constant pressure thermometer, no use. This is the first point. V proportional to T. This thermometer pressure constant. Pressure constant. VT second, third.
This is Gay-Lussac's law.
300 is the volume of a gas at T1 at constant pressure.
So this is third thermometer.
Right. Constant pressure thermometer. So it can be used minus from 0 to 600.
Sir, this thermometer also obeys Charles' law or any other law?
Charles law. This is also Charles law. So constant pressure, volume of a given mass of a gas is directly proportional to absolute temperature. P proportional T. Charles' second law. Charles' two laws. Boyle's law. At constant temperature, the pressure of a given mass of a gas is inversely proportional to volume. This is called Boyle's law. So Charles' law, P proportional to T, V proportional to T. At constant volume, P proportional to T, one law. At constant volume, constant pressure, V proportional to T is another law. Two laws, Charles' laws, only one law, Boyle's law. So this is also obeys Charles' law. So at constant pressure, the volume of a given mass of a gas is directly proportional to absolute temperature. This is called Charles' law.
Sir, sir, what is T, sir?
Pressure.
T, sir. Okay.
Is the volume. T is the temperature. Temperature calculated. What is T, Nana? What is the T? Gas T degrees C, T temperature.
So in the question they'll give and they'll ask no.
Temperature, unknown temperature calculated. T is the unknown temperature calculated.
Sir, one say the range of constant volume gas thermometer.
Which one?
Constant volume gas thermometer. Sir.
Constant volume thermometer minus 200 degrees C to minus 200 degrees C to 1500 degrees C.
1500 degrees Celsius.
Minus 200 degrees C to 1500.
Done.
So fourth one, resistance thermometer. So numerical thermometer last one. Remaining three only for theory. Important resistance thermometer. Right. So it is high and value not. It is high and positive value. Actually, resistance thermometers, actually alpha positive, and this is the alpha is equal to actually RT and R naught be the resistance at T degrees C and 0 degrees C. Then coefficient of temperature coefficient of resistance. Then temperature coefficient of resistance alpha equal to RT minus R naught by R naught into T. For example, alpha value positive. Alpha value positive means RT is greater than R naught. It's possible only for conductors. It's possible only for conductors. For conductors, actually without any forbidden gap, valence band and conduction band overlap each other. It is heated. So electrons from valence band to conduction band to space. So conductor is converted to semiconductor. Semiconductor means resistance also increases. So RT increases. So for conductors, it's possible alpha value positive. For semiconductors alpha value negative. Alpha value negative means, so this is the some energy gap is created. This is the valence band, this is the conduction band. So energy gap, forbidden energy gap, silicon 1.1, germanium 0.72. Okay, energy gap is created in between valence band and conduction band. At ordinary temperature, electrons does not flow from valence band to conduction band. It is heated at high temperature, electrons flow from valence band to conduction band. So semiconductor converted to conductor. So resistance also decreases. This is the decreases. So RT decreases are not same. So negative value. Alpha value negative. Next, third case is alpha positive. Alpha is small for constant ton, nichrome and manganese wire. As alpha is very small, it is used as a standard resistance box and potentiometer wires. This is in second year actually. Alpha positive, alpha negative, alpha small. So alpha positive means RT value increases. Okay, RT value increases with increase of temperature for conductors only. So RT value decreases with increase of temperature in case of semiconductors. This is also original in second year. Just how sir, this is the positive value, high and positive value means this is the reason, right? So this thermometer can be used to measure minus 272 degrees C to 1200. It is used to measure minus 272 degrees C to 1200 degrees. Third one, let RT and R naught, RT, R naught and R100 be the resistance at T degrees C, 0 degrees C and 100 degrees C. Then T by 100 is equal to RT minus R naught by R100 minus R naught. So T by 100 is equal to RT minus R naught by R100 minus R naught. This is a resistance thermometer. Okay, this additional information in this case. So the original let RT and R naught be the resistance at T degree C and 0 degree C. Then temperature coefficient of resistance is alpha equal to RT minus R naught by R naught into T minus 0. So originally in second year is the formula proved. So RT minus R naught by R naught into T minus 0. Alpha is the temperature coefficient of resistance. Alpha equal to RT minus R naught by R naught into T minus 0. So next one, fifth formula. Other than 0 degrees. Other than 0 degree. So alpha equal to R2 minus R1 by R1 T2 minus R2 T1. Another one, alpha 1 and R1 and R2 be the resistance at T1 degrees and T2 degrees. Other than 0. And for example, 60 temperature, 60 degrees temperature and 40 degrees temperature, or 60, 80, other than 0. So 30, 60, 30, 80, anyone other than 0. So resist R1, R2 with the resistance at T1 degrees and at T2 degrees C, then temperature coefficient of resistance is R1, R2 be the resistance at T1 degrees C and T2 degrees. T1 degrees and T2 degrees. Okay? This is only R0 to RT. Is other than 0. So RT, R100 and RT are given. So temperature is calculated by using this formula.
So total types of thermometer are how many, sir?
7. So main completed. 4 completed. Remaining 3 just only for theory. Not important. Main 4. Numerical concepts only 4. Numerical problems. Resistance important.
In that 4, resistance is important, sir.
Resistance important. 2, 3 problems are in material. Pressure, one problem. Remaining all are centigrade Fahrenheit scales.
With this thermometer completed, sir.
Maximum, right? So next one, next thermometer is thermoelectric thermometer. Fifth one. Thermoelectric thermometer. So once upon a time, this is the one chapter, thermoelectricity, one chapter is there. Old 10 years back, thermoelectricity. What is Seebeck effect, Peltier effect, Thomson effect, applications of thermocouple, Duddell's galvanometer, thermophile. Okay, so this is the one chapter. After modification, this is a complete chapter is eliminated. But last 2 years, 3 years back, this is the AIM syllabus, only AIMS, only for AIMS, AIM syllabus. AIM syllabus only thermocouple and Peltier, Seebeck effect and Peltier effect. Only 2 topics. AIM syllabus. So NEET syllabus, out of syllabus. Right. What is thermoelectric thermometer means? Thermoelectric series is the one special chapter actually. In current electricity chapter. This is the galvanometer. The hot water. This is the cold water. This is the iron. This is the copper. This is the iron. Only this is the iron. Remaining copper. And then this is the copper. Here also copper. Only this part. Okay? This is iron. 2 different dissimilar metals means different metals. 2 dissimilar metals are joined to form a closed circuit with 2 junctions. Junction means 2 different metals are kept in contact. In the copper wire, iron wire. Copper, iron wire. With 2 junctions, one junction kept in hot water, other junction kept in cold water, and EMF is induced in a circuit. Okay? EMF is induced in a circuit. This is the EMF is induced. So EMF is induced means current also induced. Current flows. Current flows in a circuit. So what is this one? Galvanometer. Galvanometer means deflection. Actually, galvanometer means actually an original topic in moving coil galvanometer, moving charge chapter. Galvanometer, conversion of galvanometer to ammeter, galvanometer to voltmeter. This is the one meter like a voltmeter, ammeter. This is a galvanometer. So galvanometer actually scale, this is the middle is 0. So this is the deflection is 30. This is also deflection is 30. So this is the one scale. Scale is divided 2 parts. One is the 0 to 30, 0 to 30. Left and right. This is the one needle. So needle is rotated on scale. So this is the galvanometer scale can be calibrated to measure the temperature of hot junction without use of thermometer. Without use of thermometer. Actually, multimeter is there. The idea multimeter in electrical shop. Multimeter means multi to measure voltage, current, potential, temperature. Anyone is measured. For example, any one cell, anyone. Okay, multi. This is the number of resistance calculated, voltage calculated, capacity calculated. So all values. This is a multimeter, multi-purpose. So this is also saying the galvanometer scale, and for example 30, for example 20, deflection is 20. Actually, one division of is equal to, for example, temperature is measured. One division equal to, for example, 0.4 degree equal. For example, this is the scale. For example, 20 into 0.4. And 8. So 8 degrees equal. 8 degrees. It's the temperature. This is called calibration. So galvanometer scale can be calibrated to measure the temperature of hot junction without use of thermometer. Without use of thermometer. This type of thermometer is called thermoelectric thermometer. It was found by Seebeck. So this is called Seebeck effect also. 2 dissimilar metals, not a different metal. So one is the positive wire and another is the metal wire. Positive iron is one metal positive, this is the copper is negative. antimony bismuth. So first metal and last metal, actually thermoelectric series. From antimony to before the lead is the zero, neutron, zero. Electrical charge is completely zero. So before lead, antimony to before lead is positive metals. After lead to antimony to bismuth, last bismuth is negative metals. Okay. So one positive metal, one negative metal are joined to form a closed circuit with two junctions. One junction is hot water, other junction is cold water, and EMF is induced. And current also EMF and induced EMF and induced current also generated in the circuit. This phenomenon is called Seebeck effect, actually. But no need this one. Just what is.
Sir, me remember chase.
How many degrees centigrade, sir? Galvanometer, 1 unit, how many centigrade, sir?
Unit. Galvanometer is the one instrument. One instrument.
Galvanometer. Calibration ఏంటి సార్? సార్ galvanometer calibration.
ఇప్పుడే చెప్పాను అబ్బాయి calibration అంటే అబ్బాయి. For example, ఇక్కడ ఒక deflection there. Multimeter. What is the multimeter?
All purpose.
This is the multimeter. అలా కాదు, this is the multimeter. So multimeter scales, number of scales are there around. This is the current scale. This is the voltage scale, temperature scale, EMF scale. Okay, so this one is resistance scale. Resistance. So needle is one only. This is the deflection. Around the deflection. Needle. And just one needle deflection. So for example, it already indicated. One deflection, current measure, one deflection is equal to, for example, current 0.01. For example, one deflection is equal to voltage measured 10 power minus 6. So, for example, temperature is measured, one deflection equal to 0.0002. For example, this is the value are indicated. So, for example, current is measured, for example, temperature measured. For example, this is the value 1, 2, 3, 4, 5, 6. Value, each value 4. So 4 into multiply this value 0.0002. So how much? 0.0008. This is called temperature value. For example, so this is called calibration. Calibration means deflection of only one deflection. So either temperature measured, temperature calibrated. So voltage calculated. So current, EMF, resistance. All are different scales, different values are there. Okay, fixed values. So how many deflections multiply with this value? So this is called calibration. Okay. Okay, clear calibration.
Yes.
Calibration means deflection of eye, multimeter deflection. This is the multimeter. This is the multimeter on 1, 2, 3, 4, 5. So then already is fixed some values under one deflection kinda. Some value, one deflection, some value. Already is fixed on scale. For example, for example, 1, 2, 3, 4, for example, is 10.
Clear.
So 10 deflections, 10 into one deflection is equal to 10 power minus 6. So how many deflections? 10. 10 into 10 power 6. This is the value for voltage. This is called calibration. Right. So it is rapidly. Time over.
3 minutes there.
Rapid. Okay. It is rapidly or quickly. Rapidly or quickly temperature. Rapidly or quickly varying temperature, varying. Varying temperature is measured. Rapid or quickly varying temperature. This thermometer can be used 252 from 250 degrees C to 3000 degrees C. From 250 degrees to 3000 degrees C. So actually this is the one formula, this one. EMF is equal to AT plus BT square. This is the one parabolic equation. Actually, graph temperature and EMF along y-axis, temperature along x-axis is the graph. Temperature also increases. This is the neutral temperature, inversion temperature. This is the critical temperature. This is the critical temperature. So temperature increases, EMF also increase and becomes maximum. So this is called neutral temperature. And the temperature increases, temperature EMF is gradually decreases and becomes zero. This is called inversion temperature. So it is acts as a parabolic path. So parabolic equation E equal to AT plus BT square.
Sir, that is 250 or minus 250?
To A theta plus B theta square. Theta is the temperature. No need.
That is 250 or minus 250, sir? Sir, అది 250 లేకపోతే minus 250?
250 plus 250 plus 250 plus 250 to 3000 plus.
సార్ ఈ ఫార్ములా నేర్చుకోవాలా సార్? EMF
no need. అవసరం లేదు, no need. Actually, in current electricity chapter, actually original, but this is also additional syllabus. Actually, need additional syllabus. Just this is the only enough. Thermoelectric thermometer, one type is a quickly or rapidly varying temperature enough, or maximum this one. You don't know it, not important enough. Radiation thermometer. So only two steps. Radiation thermometer. Radiation thermometer.
Sir, 1030.
Just only two steps. Without formula, only two lines. Radiation thermometer. It is used about up to 3000 degrees C. It is used to above 3000, above 3000 degrees, 3000.
Below 30,000.
Above 3000. It can be used to measure above 3000 degrees C. Next point, the temperature of sun is measured. The temperature of sun is measured by pyrometer. The temperature of sun is measured by pyrometer. PYROMETR, pyrometer. Last one, seventh one, vapor pressure thermometer. Vapor pressure thermometer. Vapor pressure. This thermometer can be used minus 268 degrees C to 272 degrees C. Minus 268 degrees C to 272 degrees C. It is a very low temperature. It is very low temperature. So only one topic is pending on a temperature, triple point of water. Very important.
It is low.
Sir, minus 1068 to?
It is very low. It is very low temperature.
Sir, thermal expansion not there, sir.
No. Thermal expansion of solids.
Okay.
Sir,
Solids is there.
so what can be used to measure above 3000 degrees Celsius, sir? Which thermometer is used to measure above 3000 degrees Celsius?
Above 3000 degrees.
Radiation
Thermometer.
Radiation. This is the radiation thermometer. Last one is vapor pressure thermometer. Vapor pressure thermometer only minus 268 degrees to 272. It is a low, very low temperature. Compared to thermometer.
Bye, sir.
Fine.
Bye, sir.
Thank you, sir.
Hi, sir.
Fine.